Let's take a look at the immune system. Immune system. And as its name implies, the immune system, like a lot of other systems in the human body, or the body of any animal, is composed of numerous parts. So, what's the function of the immune system? And how does it perform that function? So, the broadest definition is that the immune system is a complex network that defends the body against danger. Defense against danger. In some formulations, against danger. In some formulations, a more specific source of danger, that is, infections, is considered paramount. Infections. So, the first issue to grapple with is that the immune system is a complex network. What does that mean? Well, it means that there are a number of components, and I'll kind of list these in pictorial form, and some of them are cells, and some of them are proteins. This is a protein. These are not necessarily drawn to scale. We'll put one here that looks like this Y shape. That's called an antibody. And by interacting with one another, maybe a cell producing an antibody or another protein, and the cells influencing and talking to one another, they create emergent behaviors that carry out this function of defense against danger. So how does it actually do that? Well, to perform that function, this network screens all the material, all the matter in the body. Network screens matter. Matter, that's just stuff in the body. And that puts it in a position where it's somewhat analogous to the nervous system. The nervous system, which is a network, a complex network that screens energy. It screens energy. And you might say to me, well, David, what does that mean, that it screens energy? What I mean is that it detects energy in our environment, including inside the body, things like heat and light and pressure and sound, and it helps us modify our behavior, either consciously or unconsciously, in order to cope with that change in energy in the environment. The immune system is a complex network that screens matter instead of energy. And in that sense, it kind of works in parallel with the nervous system. This one controls the response to energy, and this one controls the response to matter. So, to do its job, the immune system has to evaluate each and every molecule that it possibly can, which is an incredible job because there are trillions of cells in your body, each with trillions of molecules, if not more, inside and trillions more molecules outside. And the immune system cells kind of grab onto and by molecular shape, by geometry, try and determine which of those molecules represent some danger, represent something bad to the body, and then it has to respond to that danger. And everything else it ought to ignore. So for the immune system, there's really only one question. And that question is what I'm in contact with now dangerous? Is it dangerous? Or is it safe? Meaning it's not dangerous. Not dangerous. That's all the immune system cares about. But we superimpose a second question on that the immune system asks. And we ask, where does this stuff come from? Because if the immune system is coping with or responding to material that comes from inside the body versus outside the body, that's going to make a difference in the manifestation of the response. So the material could come from inside the body, inside, or it could come from outside. What do you mean, outside? Well, there are plenty of molecules inside the body, the molecules that we're made of. What about outside the body? Every day when we eat, when we drink, when we breathe, there's a flux of new molecules coming into the body. And all of those have to be evaluated. A lot of them are just kind of benign tourists to the body, like food and harmless drink, as opposed to harmful drink. So if material is inside the body and is safe, like our own tissues, should there be an immune response? No, no response. No response. That's what it should do. It should leave those things alone. If something inside the body has become dangerous, why? Because maybe it's broken, maybe it's mutated, maybe it's in the wrong place at the wrong time, or it's outlived its usefulness and needs to be recycled, then yes, to neutralize that danger, there should be a response. Yes, there should be a response. What if the material comes from outside the body? Well, if the material comes from outside the body and it is dangerous, what would that be? Well, that would definitely be infections. And those include bacteria and viruses, protozoa, like parasitic organisms, and sometimes yeasts, molds, fungi. For sure, that gets a capitalization. Yes, there must be a response to that. And lastly, what if the material comes from outside the body, but it's safe, it's not dangerous? Well, then no, it doesn't represent a threat, so there should not be a response. But in almost all of these cases, there's the possibility that the immune system makes a mistake. So what would its mistake be? Well, if the immune system is encountering some material from inside the body and it is safe, it ought not to respond, but if it does, that is called autoimmunity. And by response here, I pretty much mean attack. Autoimmunity. And those are diseases that you may have heard of, such as rheumatoid arthritis or systemic lupus erythematosus or just lupus, multiple sclerosis, myasthenia gravis. There are a whole host of diseases that we believe are characterized by an inappropriate immune response or attack of the immune system on healthy molecules and tissues and cells within the body. That's all a mistake. And the diseases that spring out of that depend on what kind of attack the immune system engages in and what are the target molecules or tissues. What if there is a source of danger from inside the body, but the immune system, which ought to respond, does not? Well, that's a little bit unclear, but it's possible that certain types of cancer arise in the body on a semi-regular basis at a low rate, but that the immune system destroys them before they ever become clinically important. And by failing to do that job, if it lets something dangerous from inside the body go forth, without countering it, then that might be a cause of some types of cancer, some types of malignancies. What if the danger comes from outside the body, and we capitalize this? Yes, for sure, there should be a response against viruses and bacteria and parasites. A failure to respond to those things, a failure to attack them, causes immunodeficiency. And perhaps the most famous of those in our era is the acquired immune deficiency syndrome, or AIDS, which is caused by the HIV virus. Last but not least, and perhaps the most common in first world countries type of immune problem, is what if the immune system is encountering some material from outside the body that is not dangerous? It's totally safe. Well, we said before, it ought not to respond. This is not dangerous material. There's nothing worth responding to here. But occasionally the immune system makes a mistake and does grab a hold of some foreign but benign material, somewhat analogous to a tourist just visiting a country who is evaluated at the border and mistaken for a terrorist. And the ensuing response, in its broadest sense, is what we term allergy. Allergy. So allergy is an inappropriate immune response, or attack in this case, against a benign foreign substance. And immunodeficiency is an inappropriate tolerance of the immune system for a foreign dangerous substance. And autoimmunity is an inappropriate attack against kind of domestic, well-behaved molecules that do not represent any danger or threat. So I see that I'm out of time. In the next video, we'll discuss the components of the immune system and where they come from.